This section on DMET Console software is about two allele translation options. One is to perform translation restricted to a subset of markers, or to perform allele translation using an override file to replace missing genotypes. We've discussed in another section how marker lists can be used, but to recap, you can use marker lists that are displayed in the software to specify the subset of markers that should be genotyped. You can specify them for selecting what subset of markers you want to display and export, and you can also specify what subset of markers you want to use for allele translation. So this section describes what happens when you do allele translation on a subset of markers. To do this, you have to select the option Filter by Marker List. When you do that, you can select from a list of available marker lists that appear in your workspace, either the 3 predefined ones or a new marker list you create yourself. The DMET Plus validated by Affy 2009 marker list, for example, lists 315 markers out of the 1936 markers in the panel. The top table shows the list of star alleles or haplotypes that can be called if allele translation is supplied with all of the markers for UGT 2B7. If, however, you supply only the subset of markers that are in the validated by Affy marker list, 2 of them on UGT 2B7 are in this list, and therefore only these 2 will be used for translation. This impacts the number of star allele calls that can be made. For example, using only these 2 markers, you can still differentiate 2C from the others, but you cannot differentiate star 1A from star 1G, from 2A, from 2E, from star 3. As a result, using only these 2 markers for UGT 2B7, you can only differentiate star 2C from everything else, and in this case, the everything else is going to be called star 1A when a sample has no variation among these 2 markers. To learn more about what haplotypes can be called when you filter on the validated by Affy marker list, you can simply go to the library folder used by DMET Console, which may be in a different location than this example. There's a subfolder called Release Notes. If you go into it and jump to the UGT 2B7 marker, this Release Notes will open in your web browser. At the very top, it lists the reportable haplotypes for UGT 2B7 if you use all markers, and what the subset of haplotypes are if you use the validated by Affy 2009 marker set. Also, you can tell here which of the star alleles will be reported as the other star allele when you do this merging. So star 2C still stays as star 2C, but all the others would be called as star 1A using the list. While we're in this file, let's just look at some other things. There's also information about this gene in the sense of for a typical population, in this case 597 HapMap samples from 6 different populations. This is the breakdown of predicted calls, star allele calls, that's been observed. In terms of per marker level, how often we see the reference genotype versus the variant genotype, they're broken down in this table as well. And there's only one marker that for this gene doesn't appear that common in its variant state. In fact, this last one, 7 of the samples called something other than ref. It could have been a no call or possible rare allele, which might be a heterozygous variant. Be aware that the validated by Affy 2009 marker list is not the only information that you have available to judge the quality of the data. For example, if you go to the Affymetrix website and do a search not on the product catalog but across the whole site on DMET verified markers, you'll get a link that lists the comparison of DMET Plus genotypes against reference data, either from HapMap or sequencing, and the results of that. And it's broken down by genotype call. Another optional feature of allele translation is to perform translation with call override. What does this mean? Well, normally what you do is you'd take your chip files that contain your genotypes and you'd perform translations on them, and it would generate a number of reports, including a file called the uncalled report. This report tallies all of the missing data among markers that are used for translation, including ones that have no calls or possible rare allele calls. What you may decide to do is fill in that missing data with your best interpretation of what those genotypes should be, either by looking at the marker plots for these markers and predicting your best guess as to what the call is, or with another technology. But in the end, you can fill in your missing data with your expected answer, and DMET Console does allow you to feed in that supplemental data to improve upon the translations that happen. Now, I'm reading this from the DMET Console help. There's a section called Perform Translation with Call Override. You can read about this in more detail, but the basics of it is to take the uncalled report, save a copy, call it as an override, and fill in the missing information like no calls or possible rare alleles with your predicted values. And as a guide, this file lists the legal values that you can put in as base calls for each row. For tracking information, if you do override the raw genotypes with the supplemental genotypes, the reports will have an override field that you can supply a comment on. The reports will also list the original base call in addition to the override base call. Once you have that override file, you can go back to DMET Console and select the override specific genotype calls option, check to select the override file that you just created, and redo your translation.